Hello students, welcome to EPG Pathshala. I am Vinodini Kapoor and I am teaching in the Faculty of Management in Chandigarh. Today, we are going to discuss about the module System Design, and we will learn this through data flow diagrams and entity relationship diagrams under the paper Management Information Systems. After completing this module, students will be in a position to understand what are the basic concepts of system design. They shall understand system design via the use of data flow diagrams and entity relationship diagrams. They would be in a position to list what are the various notations and symbols for both of these diagram categories, and they will be in a position to understand what are applications of DFD and ER diagrams. We will also list certain differences between both of these diagram types. A picture is worth 1,000 words. Now this sentence has a lot of meaning in itself. A data flow diagram is a traditional visual representation of the information that flows within a system. A neat and a clear pictorial DFD diagram can depict a good amount of the system requirements graphically. It can be a manual, automated, or combination of both. It shows how information enters and leaves the system, what particular changes the information, and where the information is particularly stored. The purpose of a DFD is to show the scope and boundaries of a system as a whole. It may be used as a communication tool between the system analyst and any other person who plays a part in the system that acts as the starting point for redesigning a system. Data flow diagram is a highly effective technique for showing flow of the information through the system. DFDs are used in the preliminary stages of system analysis to help understand the current system and to represent a required system. The data flow diagram themselves represent external entities sending and receiving information. The process that changes information, the information that flows among themselves, and where the information is actually getting stored. Data flow diagrams are a form of information development tool, and as such it provides key insights as to how information is transformed as it passes through a system.
Students, we now look into the intricacies of the system design. System design stage gives answers to the question how the system will accomplish the objectives. System design consists of design activities that produce system specifications, satisfying the functional requirements developed in the analysis stage. System design consists of two steps, the first being the conceptual design and the other being the detailed design of the information system.
Okay students, let's now try and understand what do we mean by the conceptual design. It represents structure of the management information system, and it takes into account input from the statement of management information system requirement and objective of the MIS. The output of this stage is the performance requirement of those who will be developing the detailed design. Features of the new system are specified. The cost of implementing these particular features and benefits to be derived are also estimated. If the project is still considered to be feasible, we move to the design stage. Conceptual design in itself is not the end of the design process. Rather, it serves as a basis for the detailed MIS design. The performance requirements specified by the conceptual design becomes inputs to the detailed design phase, in which these are further refined, detailed, and then finalized to be called system specifications. Now we will try and understand what is a detailed design. At this particular stage, design of the system becomes more structured. A structured design is a blueprint of a computer system solution to give problems having the same components and interrelationships among the same components of the original problem. The input, the output, the databases, forms, codification schemes, and processing specifications are drawn up in much detail. In the design stage, the programming language and the hardware and the software platform in which the new system will run are also decided. In order to make a detailed design, first of all, the system designers have to gain support of all the staff members from the top to the bottom level. To seek their acceptance, it's better to involve them in the designing process. The designer uses 4 scores for the design of the management information system. They are task for meeting, for larger system interview with the top, intermediate level manager, and a selected group of operating staff. Study the internal and the external source document, and in the last, personal observation of operations and communications. The detailed design is done in the area of designing user interface, data design, and process design.
Let us now look at what are the differences between the concepts of the conceptual and the detailed design. The conceptual design gives the overall performance specification of the management information system, and the detailed design gives the construction and the operating specifications. Broadly, the differences can be summarized as the conceptual design will give us a structure and the overall performance specification, while the detailed design gives the operational and construction specification. The input of the conceptual design is a statement of management information requirements and the objectives of management information system, while the input of the detailed design is the conceptual design report. The conceptual design ends from where the detailed design of the proposed system will start. So the conceptual design provides the base to the detailed design, that is, output of the conceptual design is used in the detailed design. Lastly, conceptual design provides the structure, while the detailed design makes the structure to be operational. We'll now come to the main point of the data flow diagrams. When it comes to conveying how information data flows through various systems and how that data is transformed in the process, the DFD or the data flow diagrams are a method of choice over the technical descriptions for 3 principal reasons. DFDs are easier to understand by technical and the non-technical audiences. DFDs can provide a high-level system overview, complete with boundaries and connections to other systems. The data flow diagrams can provide a detailed representation of the system components. Data flow diagrams help system engineers and others during initial analysis stage to visualize a current system or the one that may be necessary to meet new requirements. System analysts prefer working with the data flow diagrams, particularly when they require a clear understanding of the boundary between existing systems and the postulated systems. Data flow diagrams represent the following: external devices that are sending and receiving data, the processes that change the data flow themselves, and data storage locations. A data flow diagram can be used to show the information between different components of the management information system. We'll now discuss what are the data flow diagram symbols and notations. The four primary symbols are, as you see in the diagrams correspondingly, the first being the entity. We then look at the process symbol, the data store, and the data flow. So as you see the diagram, it shows flow of the data when the MIS is used to produce a summary report for the company directors that gives weekly reports made by the manufacturer. Data flow diagrams consist of the basic four components. Let us discuss each of them individually. The entity. The entity is the source or the destination of data. The source in a DFD represents these entities that are outside the context of the system. Entities either provide data to the system that are referred to as a source or receive data from it, which are referred to as a sink. Entities are often represented as rectangles. A diagonal line across the right-hand corner means that this entity is represented somewhere else in the DFD. Entities are also referred to as agents, terminators, or source or sink. The process. The process is a manipulation of work that transforms data, performing computations, making decisions, or directing data flow based on the business rules. In other words, a process receives input and generates some output. The process symbol names are, for example, simple verbs and data flow names such as submit payment or get invoice. And usually they describe the transformation which can be performed by people or machines. Processes can be drawn as circles or a segmented rectangle on a DFD and include a process name and a process number. We'll now look at what is a data store. A data store is where a process stores data between processes for later retrieval by the same process or another. Files and tables are considered data stores. Data store names are simple but meaningful, such as customers, orders, and products. Data stores are usually drawn as a rectangle with the right-hand side missing and labeled by name of the data storage area it represents, although different notations may also exist. We now look at the fourth symbol of the data flow. It represents movement of data between the entity, the process, and the data store. Data flow portrays the interface between the components of the data flow diagram. Flow of data in a DFD is named to reflect nature of the data used. Now these names should be unique within a specific DFD. Data flow is represented by an arrow where the arrow is annotated with the data name. For example, the representation of the DFD diagram shows different entities and the different processes or the data stores, such as the order processing system, the stock processing system, the credit control system are, as you see, they are all entities. Now these are further related to the weekly analysis and the summary report, which are also entities. However, their corresponding data is stored in the data stores such as the sales data file, the stock data file, the customer data file. Let's take up an example now. We look at the food ordering example. Now in context of this, a context diagram, which is again a data flow diagram, will show at the top level or otherwise termed as level 0. At this level, there is only one visible process node that represents the functions of a complete system in regard to how it interacts with the external entities. Some of the benefits of a context diagram are that it shows the overview of the boundary of a system. No technical knowledge is required to understand the simple notation. It is very simple to draw, to amend, to elaborate as its limited notation. The context data flow diagram for a food ordering system is represented below, contains a process which represents the system to model, in this case, which is the food ordering system. It also shows participants who will interact with the system and are called the external entities. In this example, supplier, kitchen, manager, customer are all entities who will interact with the system. In between the process and the external entities, there are data flow connectors that connect the existence of information exchange between the entities and the system. Context data flow diagram is the entrance of a data flow model. It contains one and only one process and does not show any data store.
Okay, students, let's take up the case of the food ordering example. From the supporting diagram, we observe that the food order system data flow contains three processes. There are four external entities and two data stores. Based on this particular diagram, we know that a customer can place an order. The order food process receives the order and forwards it to the kitchen. It stores it in the order data store and stores the updated inventory details in the inventory data store. The process also delivers a bill to the customer. Managers can receive reports through the generate reports process, which takes inventory details and orders as inputs from the inventory and order data store respectively. Manager can also initiate the order inventory process by providing inventory order. The process forwards the inventory order to the supplier and stores the updated inventory details in the inventory data store.
Okay, students, now let's come to the second part of the module. This concept is referred to as the entity relationship diagram or the ER diagrams. The ER diagram is a data modeling technique that graphically illustrates an information system's entities and the relationships between those entities. An ER diagram is a conceptual and representational model of data that is used to represent the entity framework infrastructure. The elements of an ER diagram are again primarily the entity, the relationships, and the attributes. ER diagrams are very crucial to creating a good database design. It is used as a high-level logical data model, which is useful in developing a conceptual design for databases. An entity is a real-world item or concept that exists on its own. Entities are equivalent to database tables in relational databases, with each arrow of the table representing an instance of that particular entity. The attribute of the entity is a particular property that describes that entity. A relationship. It is the association that describes the interaction between entities. Cardinality in the context of ER diagram is the number of instances of one entity that can or must be associated with each instance of another entity. In general, there may be one-to-one, one-to-many, or many-to-many relationships.
The entity relationship diagram considers two real-world entities here, that is, an employee and his department. The employee has attributes such as the employee number, the name, the department number, etc. Similarly, a department number and name can also be defined as attributes of a particular department. A department can interact with many employees, but an employee can belong to only one department, and hence there can only be a one-to-many relationship defined between the department and the employee. Now, in the actual database, the employee table will have a department number as a foreign key, referencing from department table to enforce the particular relationship.
Let's look at what the ER diagram explains to us. There are more elements which are based on the further important elements. They are the weak entity, the multi-valued attribute, the derived attribute, the weak relationship, and the recursive relationship. Cardinality and ordinality are two other notations that are used in ER diagrams to further define relationships. ER diagrams are most often associated with complex databases that are used in software engineering and IT networks. The entity. An entity can be a person, a place, an event, or object that is relevant to a given system. For example, a school system may include students, teachers, major courses, subjects, fee, and other items. The entities are represented in the ER diagrams by a rectangle and named using singular nouns. Now let us understand what is a weak entity. A weak entity is an entity that depends on the existence of another entity. In more technical terms, it can be defined as an entity that cannot be defined by its own attributes. It uses a foreign key combined with its attribute to form the primary key. An entity like the order item is a good example for this. The order item will be meaningless without an order, so it depends on the existence of that particular order. We will now look at the ER diagram symbols and notations and understand them individually. As you can see in the diagram below, the various notations are represented. Let us look at what the attribute is. An attribute is a property or a trait or a characteristic of an entity, relationship, or other attribute. For example, the attribute inventory item name is an attribute of the entity inventory item. An entity can have as many attributes as necessary. Attributes can also have their own specific attributes. For example, the attribute customer address can have the attribute number, street, city, and state. Now these are called the composite attributes. Some top-level ER diagrams do not show attributes for the sake of simplicity. In those that do, however, attributes are represented by oval shapes. The multi-valued attribute. If an attribute can have more than one value, it is called a multi-valued attribute. It is important to note that this is different to an attribute having its own attributes. For example, a teacher entity can have multiple subject values. The derived attribute, an attribute which is based on another attribute. However, this is found very rarely in the ER diagrams. So what we see here is, say an entity named circle can have a derived attribute which could be the radius or the area. The derived attribute is represented by the area. Relationship. A relationship describes how entities interact. For example, the entity carpenter may be related to the entity table. And how do we denote this? We denote this by the relationship between the carpenter and the table. And what is the relationship? That the carpenter makes the table. Relationships are represented by diamond shapes and are labeled using verbs. Recursive relationship. If the same entity participates more than once in a relationship, it is known as a recursive relationship. In the below example, an employee can be a supervisor and can be supervised so that there is a recursive relationship. In particular, ER diagrams are frequently used during the design stage of a development process in order to identify different system elements and their relationships with each other. The connecting lines. These are solid lines that connect attributes to show the relationships of entities in the diagram. Cardinality. This specifies how many instances of an entity relate to one another of another entity. Ordinality is also very closely linked to cardinality. While cardinality specifies occurrences of relationship, ordinality describes the relationship as either mandatory or optional. In other words, cardinality specifies the maximum number of relationships and ordinality specifies the absolute minimum number of relationships. The elements writer, novel, and consumer may be described using the ER diagram as we can see below. In this particular diagram, the elements that are inside the rectangles are writer, novel, consumer. Now, what they do is specified in the relationship between the entity, the writer, and the novel. So, the writer creates the novel. Now, let us understand what is the relationship between the consumer and the novel. It is stated as the consumer buys the novel. Let's try and understand this concept by another example. The inventory software used in a retail shop will have a database that monitors elements such as purchases, item, item type, item source, and item price. Rendering this information through an ER diagram would be something like this. So we have entities such as the shopper, the item, and then we have the attributes such as item type, item price, item source. And the relationship between the shopper and the item is depicted by the relationship notation that shows that the shopper buys the item. The next topic that we will discuss in the module is building effective ER diagrams. What we do here is, first and foremost, it's very important to understand that we have to identify all relevant entities in a given system and then determine the relationship between the entities. An entity should only appear once in a particular diagram. It is essential to provide a precise and appropriate name for each entity, the attribute, and the relationship in the diagram. Terms that are very simple and familiar always beat the vague, the technical sounding words. In naming entities, remember to use singular nouns. However, objectives may also be used to distinguish entities belonging to the same class, say part-time employees and full-time employees. Meanwhile, attribute names must be meaningful, unique, system independent, and easily understandable. It is important to remove vague, redundant, or unnecessary relationships between the entities. It is essential to note that never connect a relationship to another relationship. Also, it is very good to make effective use of color. You can use colors to classify small entities or highlight areas in the diagrams. Now let us see how do the entity relationship diagrams and the data flow diagrams differ with each other. Data flow diagrams and ER diagrams are different data models that are mainly used for organizing business data for proper communication between members of a group. The data flow diagram shows how data enter a system, are transformed in the system, and how it is stored in it. Meanwhile, the ER diagram represents the entity model and will show what a system or a database will look like, but it will not explain how to implement it. The data flow diagram and the ER diagram are formulated using different rules. With the data flow diagram, each of the processes and the storing should have at least one data flow going towards it and one leaving it. All the data must have to go through a certain process, and all the processes in a system should be linked to a data store or another process. With ER diagrams, all the entities should represent a group of similar things. All the definitions in ER diagrams should be unambiguous. The data flow model is a multi-level representation that commences with abstract information and includes multiple decomposed levels. The ER model represents the system data and includes an elaborate description of the relation between the data. The data flow diagram is represented by ovals, rectangles, or circles and is named with a single word. Arrows represent the flow, and ovals or parallel lines represent the storage. The ER diagram is represented by a rectangular box, and the diamond represents the relationship between the entities. Cardinality is represented by lines or the standard notations. Both the data models also come with many shortcomings. DFD is simply not enough to describe a system completely. Moreover, the use of different symbols can create confusion in the users. The DFD cannot specify computations in a process. The ER diagram does not show interaction between the model or the data and how this can change in a particular system.
So students, let us summarize what we have learned in this particular module. The main objective of the system design is to produce system specification which can then be converted into an information system for use in the organization. However, the system design is a creative activity and considers to evolve through different levels of design, which are the conceptual design and the detailed design. The conceptual design, which is also called feasibility design, sets the direction of the MIS project and provides performance requirements. The output of the conceptual design, that is, performance specifications, are taken as an input to the detailed design to produce system specifications. The system specification generated are handled over to the computer programmer for translating into a physical information system. The system specification, called the detailed system design or the logical system design, provides all details of inputs, outputs, file, database control, and procedures. For ensuring an effective, efficient, and successful MIS, the system analyst must not rush through the phase. Rather, each and every step must be undertaken very carefully to prepare a detailed system design. The data flow diagram provides a visual representation of the flow of information within a system. By drawing a data flow diagram, you can tell the information provided by and delivered to someone who takes part in the system process, the information needed in order to complete the process, and the information needed to be stored and accessed further. The entity relationship diagram are commonly used in conjunction with the data flow diagram to display contents of a data store. They help us to visualize how data is connected in a general way and are particularly useful for constructing a relational database. Thank you.